Hello guys, this is Mishako H, and as I promised in the last video, I'll be starting every video with the class, as you can see, and the main method already created. So in this video we're going to be discussing about floating point literals. We've already done floating points, but we did not talk about how to present floating points in scientific notations. So the previous program basically presented it in standard notation. So floating point literals is basically having it in standard notation and scientific notations. Okay, standard notation consists of a whole number component followed by a decimal point followed by a fractional component. For example, when you say 2.0, 2.35, 3.14, like the pi, okay, 0.6666667 and many others. Okay, but scientific notations uses a standard notation, floating point number plus a suffix that specifies a power of 10 by which a number is to be multiplied. The exponent is indicated by an e, or it can be capital, it can be a small letter e, and then followed by a decimal number which can be positive or negative. So usually for example, when you're presenting something like 1.0 times 10 raised to negative 19 scientifically, so you can just write 1.0 and then e and then that negative 19. Okay, so e is like what we usually present as times 10 raised to. So that number after, it's the power, which is the number raised to, for example, raised to negative 100, raised to positive 100, raised to negative 5. But instead of writing raised to plus 100, you can just write 100, because a number without a sign will be assumed to be positive. Okay, so let's have a number double STD notation, and then we have another one which is scientific notation. Okay, so we have two doubles declared, and then we can say our STD notation is equals to 6.0023. okay, and our psi notation is equals to 6.12 e 15, for example. Okay, I think psi notation is wrong, that's why it's giving us a warning. And then to format the code, I'll just press Ctrl Shift F, so it automatically formats it for me, put it in order the way I want it. So basically this e is telling us the power for this number is 15. You can put positive here, but 15 is alright. Okay, and then if I'm going to try and print out these things, so you remember, you write sysout, control spacebar, it will autocomplete. And let's start with std, control spacebar, you'll get the suggestion on what you should do. And we can try another sysout here, control spacebar, and scientific, control spacebar to get what we want, and then control S to save it, that's save, and run the code. So basically you can see we're getting back what we wanted, and you can do anything with this mathematically. So if I say this one times 10, or let's say times negative 100, and this one plus 3.21, so basically it will still give us a solution, as you can see. Okay, so as you can see, this one we're getting negative because I multiplied it by negative. So let's try positive, and you can see you're getting something else, e raised to 17. Why? Because we are adding two more zeros which will add to the power. So if we say 10, it will be 16. Okay, that's how to present the standard and scientific notations. The first one being standard because we are writing it in the normal form, and the second one being the scientific notation, as you can see, e to represent exponent. So our exponent there was 15. Okay, under these floating point literals, it's also possible to present hexadecimal numbers or hexadecimal floating point literals. So what we do is just the same way we did for scientific notation, but the exponent, which is called binary exponent, will be represented by letter P. Okay, P for what's that? Planet. Okay, never, it's very difficult to speak English sometimes. Okay, so basically what you do, for example, you can write 0x, which we did in the integers. That's how to declare a hexadecimal number, and then place the number with its decimal value and then put the binary exponent. So what you do, for example, we can say, let's declare another variable here, which will be hex notation. These things are rarely used though, so let's have it have some number, and then is equals to, let's try something like 10.2, and then we have P raised to 2, which is, that's our binary exponent. But now remember to make this one a valid hex. Okay, so I should have just said A because A is 10. To make this one a valid hexadecimal number, you remember we have to do 0x. Okay, so that's why you see the error goes away. So anytime you're making hexadecimal, you declare it using 0x, or you precede it with 0x. Okay, so if we going to print these, for example, okay, so if I'm going to save it by pressing Ctrl S and run it. So you see I get 40.5, which is in decimal form. So from hexadecimal, the answer will come out as decimal notation, but this shows you we are able to use hexadecimal numbers. Okay, so lastly, it's also possible to present a number. If it's very long, from JDK7 you can use underscores. So let's say underscore num. Okay, that's another variable, and I'm going to declare it right here. Okay, is equals to 2, and then underscore 000, something like that, anything as long as you want, and then you can put point 1 2 3 underscore 4 5 6 underscore 7 8 9. Okay, so assuming that this number was, these numbers were similar, like for example everything is 1, if you put them together and you're copying it from somewhere, it's very difficult for you to read the numbers. So the use of underscore, as we did in integers, is just meant to make your code easy to do, make it easy for you as a programmer. So I'm just going to change this. So let's save it, Control S, and run the code, and you can see it run it and removes the underscores. So what happens, it made it into scientific notation. As you can see it here, it presented E, meaning we have a positive an exponent of 9, which is that's 9 zeros. So you can multiply by it, push it to the right 9 times, push the decimal points to the right 9 times, and you'll possibly get this number. So if you have any question, just ask. Thank you for watching, and don't forget to like, subscribe, and comment. Otherwise, see you in the next video. Goodbye.